This is Jack Jackson. We're going to be looking at a particular homework problem on triangular distributions today. So I'm going to go to my stat lab here, and 3.2 and 3.3 homework on triangular distributions. And let me see if I can find the question that I want to work on. Let's see here. Oh, this is a good one. Let's take a look at this one here. Suppose that x is a random variable that is triangular, 6, 17, 9. Answer the following questions concerning this distribution. And you have to scroll down because there's several questions. It goes 1 through 14. And it says, in this case, we're going to round our final answers to 4 decimal places using decimal numbers. And remember always that we only round off our final answers, not anything that we compute as we go along. So some of the things we're going to compute as we go along, we're going to prefer to use fractions, but only what we type in the blanks will be decimals. So first of all, what does this mean, triangular 6, 17, 9? Well, it means to the left of 6, there's nothing there. So the graph of the probability density function on the x-axis for x values, it's on the x-axis for values less than 6 and also for values greater than 17. And then the mode, that is the highest value, occurs at 9. And then what does the graph look like? Well, it's made up of pieces that are triangular shaped, so linear pieces. This is going to make us a triangle in the middle. So this is 6, 17, 9. So we can start the A at 6, and so to the left of 6 we see that it's 0, and this should be 17, so to the right of 17 it is 0, and the mode occurs right at 9. Let's see if I can get it. That looks like as close as I'm going to get to 9 there. 9. And so this is what the graph looks like. So here's your 6, here's your 17, your 9 is in the middle. It goes up a certain height. So one of the first things that we're going to have to do is figure out what is this height. Well, remember, this is a graph of a probability density function, a PDF. And in a PDF, its areas under this curve, between the curve and the x-axis, those areas represent probabilities. So we know that the total probability that something happens has to be 1. And so the total area of this triangle that we have with the x-axis on the bottom and these two linear pieces from our distribution in the PDF on the top, that this triangle must have an area of 1. Notice there is no area between the x-axis and the curve to the left of 6 or to the right of 17. So we can basically ignore to the left of 6 and right of 17. The only thing that really matters is between 6 and 17. So let's call this height h. And so we have a basic setup that looks, it looks something like this, roughly speaking. And we know that the height here is h. And we have a base here. Well, this particular one, we look back at it, runs from 6, right here at 6, to over here at 17. Okay, so that's 6 here and 17 here. So that means this base has length 17 minus 6 is 11. So that's 11 units long for the base. Well, we know that when we're talking about the area of a rectangle, we're talking about how many of these little squares will fit inside of it. Well, of course, that's just base times height, but notice that the area of the triangle, the entire area here of the triangle, is half the area of this rectangle, because this little piece here is half of this rectangle, and this is half of that rectangle. So the area formula for a triangle, is 1/2 base times height. Well, the height we don't know yet, it's h, but the base we found is 11. So we have this formula. Okay, but wait a minute. We know the area is 1. So 1 is 11/2 times h. if we multiply both sides of this equation by 2 elevenths, the 2 and the 11 cancel, and we get h is, well, 2 elevenths times 1 is 2 elevenths. So that's the height of the curve. If we wanted to do a decimal approximation, we can use our calculator. Let's try that again. 2 divided by 11. And we see that that's actually 0.18 repeating. 1818, etc., etc. So let's go back to here. I think it asks us the maximum height when it happens at the mode. Notice that really it doesn't matter where the mode is here, that height doesn't change and that area doesn't change. So all of these different modes here give us different shaped triangles, but the height stays the same, the base stays the same, and the area is always 1. Let's get back to our example where we have it at 9. Okay, there we are. So the maximum height happens at the mode, and this is it right here, so we can enter that in, 0.1818. The next one's a 1, so that rounds off to that. 4 decimal places. Now compute some following probabilities. Probability that x is less than 9. Okay, this is, so the probability that x is less than 9 really is just between 6 and 9, because there's nothing to the left of 6. So notice that that gives us a base here from 6 to 9. Okay, we're finding an area that looks like this. It goes from 6 to 9. So that gives us a base, this time of 9 minus 6, or 3. And our height here is this same height here, 2 elevenths. Height. And we want to find that area. That is, you can see it more accurately sketched out over here. Okay, and so it's a base of 3 and a height of 2 elevenths. So let me just go ahead and now we figured out that height is 2 elevenths. Okay. And now the base is 3. So what's the area? That area is the probability that x is less than 9 is the probability that x is between 6 and 9. And that is 1/2 base times height. So we're just doing the area of a triangle, a right triangle in fact. And so the base we found was 3, and the height was 2 elevenths. Let's see, we get the 2's cancel here, and so we get 3 elevenths. 3 elevenths is a repeating decimal, 0.27 repeating. So this one is 0.2727. The next one's a 2, so that would round off like that. What's the slope of the graph from 6 to 9? So we're looking at this part right here. Now remember, what are the coordinates of this point right here? Well, they're whatever the mode M is and the h. So, and this is the point 6, 0. So when we're looking at this part of the graph, this is h, this is m. So this is MH, which in our case is 9, 2 elevenths. So this H is 2 elevenths. And this is the point, y is 0 and x was 6. 6, 0. And so if we want to find the slope, what we're doing is we're going seeing how far we go to the right and up. So delta x is we go to the right from 6 to 9, this is 9, This is 6. For 6 to 9, we get 9 minus 6, x2 minus x1, or we're going to the right 3. Here it is at the scale over here. 1, 2, 3. And how far up are we going? 2 elevenths. So that is the vertical change. So this is actually delta y. So remember that the slope, lowercase m, is the slope, and that is equal to delta y over delta x. That is delta y over delta x. That's the vertical change over the horizontal change. Well, vertical change is 2 elevenths. Horizontal change is 3. So 2 elevenths divided by 3 is 2 elevenths times 1/3 is 2 over 33. I'm going to call that m sub 1. That's the slope of this part right here. Here it is to scale over here. Slope is 2 elevenths. 2 over 33, excuse me. 2 over 33. Let's do that as a decimal. 2 divided by 33. 0.60606. So 0.06 repeating is the slope. Now we're going to use the 2 over 33 in our further calculations, but we'll round that off to 4 decimal places for the answer here. 0.0606. Okay, so what's the equation of the line? Well, it's that slope. Round it off. And then it's x minus the x-intercept, which is 6. So remember, in general, when we're talking about a line, here, and it crosses the x-axis at x sub 0, comma 0, it has a slope m. Okay? The equation, or one way you can write the equation, is y equals m, x minus x sub 0. So in our case, the m was 2 over 33, and the x sub 0 was 6. So the equation of the line is y equals 2 over 33 x minus 6. Now this makes sense for the part that looks like that. That's this part, which is only x's from 6 to 9. So this is x's going from 6 to 9. And of course this y is PDF of x. So we have part of the formula. Okay, the formula is in 4 parts. 2 of them are real easy. The 2 of them are just 0. So it's 0 when it's less than 6, 0 when x is less than 6, 0 when x is greater than 17, and now we know what it is here. Now the reason why that can be useful, if we want to find an area, say something that looks like, let's back where it goes, something like this, we need to find the height. If we want to find the height, as long as this point L is anywhere on this piece, we can use that formula that we just figured out to find that height. Or if we have a height here, we can find that height. So if we want to find areas like any of these guys here, then we need to know the heights of them. And that's where that formula comes into play. So let's go on. And again, I'm not going to use this rounded off version. I'll use the one with the fractions. So let's do the slope on the other part from 9 to 17. From 9 to 17, we're in this part. Well, let's see what we have there. So for this part, it's coming down here. Here's the x-axis. Okay, so this point here on the x-axis is 17, comma 0. This point here is still at the mode, so there's our same height of 2 over 30. Let's see, what is the height? 2 elevenths. 2 elevenths. Okay? And so what do? Well, we're going, as we go from this point here, which is 2/11 tall, and the x is 9, I believe it was. 9. So this is the point 9, comma, 2/11 right there. So notice that we're going down and to the right. So delta x is 17 minus 9, which is, how much is that? 8. And delta y is negative 2/11. You're going to right, you're positive, left, negative. Down is negative, up is positive. So notice we're going down and to the right. So the slope, we'll call it slope 2 for this decreasing piece. And of course we know it's going to be negative because it's falling or decreasing there. Is delta y over delta x. So it's negative 2/11 for delta y and 8 for delta x. So it's negative 2/11 divided by 8. Okay. Which that slope 2 is now negative 2/11 times 1 over 8. Which, let's do a little canceling here. First of all, we get a negative. 1 at the top, the 2 and the 8 cancels the 4. 4 times 11 is 44. Negative 1 over 44. Let's go ahead and figure out what that is in decimal version. Negative 1 divided by 44. And that's negative 0.027 227. And then after that, it looks like the 2's and the 7's repeat like that. So 27, 27, 27. So that's where it is exactly, or if we round it off to just 4 decimal places, 0, 2, 2, 7. The next one's a 2. So that's what we're going to enter for the value in the computer. But the actual value is, we're going to use a fraction. 0.0227 would be the answer that we put here. Okay, so the equation of the line, well, that's the same slope. And then it's times x minus, where this one crosses the x-axis, which actually is at 17. So look back at the graph. We know it's just a slope times x minus the x-intercept at 17. So what's the equation for this part? The slope, x minus 17. So now we can write down the full formula for the PDF. Okay, for x is less than 6, it's 0. For x is between 6 and 17, it is, what do we have up here? Here it is, 2/33 x minus 6. And for x's, I'm sorry, that's not up to 17. That only works up to what point? Up to the mode, which is 9. Then from 9 up to 17, then the formula changes to this new version here, or this one, negative 1 over 44 x minus 17. And then it's 0 again for x is greater than 17. And so we actually get a piecewise defined function for the PDF. Okay, so these two, of course, these 0 parts we don't really care about. It's this part in the middle, but this formula right here gives us the height at any point along here in this first piece. And second formula is going to give you a height of any point along here in this piece. And that's going to be useful for us. Okay. So now let's find some probabilities. Probability that x is less than 8. Okay, so let's look at the picture here. X is less than 8 is an area over here. Less than 8, really might as well say between 6 and 8, because there's nothing to the left of 6, so it's this brown shaded area that you see here. Turn these labels off. Okay, so this area D here, the brown area, is what we're looking for. Okay, so let's see if we can figure that out. Well, it's just an area of a triangle. We just need to know 1/2 base times height. So what is the height? Well, the height is just this PDF evaluated at 8. So the y value here is the height. So we go back to our formula, plug in 8 in this formula here, 2 over 33, so let's write. So the probability that x is less than 8 is the probability that x is between 6 and 8, which is 1/2 base times height, because it is that area of a triangle. Okay, so what does that give us? Well, 1/2. What about the base? Well, the base here is going to be from 6 to 8. That's a distance of 2. We found that by doing 8 minus 6 is a distance of 2, so that's the base. Okay, what's the height here? Well, the height, we use this formula, 2 over 33, and we do 8 minus 6. So this is actually 8 minus 6 is 2 times 2 over, this is 4 over 33. We'll multiply that out. So there's the height, and that's the height right here. So that height is, over here the height is 2 over 11, but here it's 2 over 33. It's shorter. It's a third. 4 over 33, 2/3 of what it is here. Yeah, that looks right, about 2/3. Okay, so, well, let's go ahead and multiply this out. See, the half and the 2 cancel, so 4 over 33 is that probability that we're looking for. That's the exact value, and this particular one doesn't ask you to put it in a fraction. You always have to watch these things in my stat lab. Sometimes they ask for fractions, sometimes they ask for decimals. This is 0.12 repeated, or if we round off, 1212, which is the form they're going to want for this particular one. Okay, now we want x is greater than 14. What's the probability there? Okay, let's look back at our picture. Now we're looking at an area over here. And again, I'm going to turn these labels off. Okay, and we want greater than 14, so basically we should say it's between 14 and 17, right? So the probability that x is greater than 14 is the probability that x is between 14 and 17, because there's nothing to the right of 17. Okay, so again, this is an area of a triangle, so again, it's just 1/2 base times height. Anytime I have you figure out something by hand on an area, it will be something that's either a triangle or a rectangle. That's it. So let's go back here and see if we can figure this out. It goes from 14 to 17. That's a base of 3. We found that by doing 17 minus 14 for that a length of 3 there. So that's our base. What's our height? Okay, well, our height is going to be the height right here at 14. Well, now we need to do the formula that goes with this piece. Somewhere I have that up here. Negative 1 over 44 x minus 17. Negative 1 over 44 x minus 17, but x is, where are we? At 14. Right? So that's negative 3, cancels that out, makes a positive height. Those two negative. This one will always be negative, and this will be negative, so they'll cancel each other out. So this is 9 over 88. Okay, 0.1027227, excuse me, 10227, and then 272727 from there on out. So here's exact value. The 2 and the 7 are the repeating. So to 4 places, that's 102, and then the 27 is going to round off to 3. Because of the getting this exactly at 14 is difficult, this is off just a little bit, but anyway, you can get the basic idea. It's pretty close. So what was the exact value? 9 over 88, and we're going to enter in 0.1023. Okay, between 7 and 9 this time. Okay, so let's see if we can see that. Okay, 9 is here, 7 is about here. So we've got an area that looks like this. Well, that's actually a right trapezoid, and we can use a formula for a right trapezoid if we want, but I think it's probably easier if we just try to remember the area of triangles. So we can take the area of a triangle here, big triangle, and then subtract off the little triangle here. In other words, go from this point A up to the top here, back straight down, that big triangle, and then subtract this little unshaded triangle on the left. Okay? So between 7 and 9. So we're looking at a situation like this. 7 and 9, this is 6. Okay? And we're looking at a shape that looks like this. So we want to find this whole triangle. So the probability that x is between 7 and 9 is the area of a big triangle, 1/2 base 1, height 1, minus 1/2 base 2, height 2. Okay, so let's see if we can figure this out. So the big triangle, actually we've already done this one, has a base from 6 to 9, which is 3, and a height of, well, remember this was our basic height. I think we got that listed over here. At the highest point, that was 2/11. So this is 2/11. Okay, so this turns out to be 3/11. We'd actually already computed that earlier. If we could go back to what we computed earlier and just pulled it down, but we'd be sure and bring the fraction version down. Not anything that's rounded off. We'll round off at the end. Now, we need to take this smaller triangle here that's unshaded, find its area. Well, it has a base of 1 and some height. So base is 1. That was 7 minus 6. And what is its height? Well, this is where you need to go back to that formula again. Here's our formula. We're using the circled part. 2 over 33 times x minus 6. So that slope of that piece was 2 over 33. And then we have the x value minus 6. The x is 7. So again, this is the same value here of the base, 1. But now we have the slope. So this is 1/2. Base is 1. Height is 2 over 33. 7 minus 6 is 1. 1 times 2 over 33 is 2 over 33. Multiply that out, we get an area of 1 over 33. So this area The big area of the whole triangle is 3/11. The area of the unshaded part is 1 over 33. And so if we just subtract, we can get that. Now I'm going to multiply by 3 over 3 here to get 9 over 33 to get a common denominator. And so we get 8 over 33. Okay, 8 over 33 in decimal form. Another repeating decimal here. 0.24 repeating. So approximately 2424. Alright, now how about between 9 and 15? Okay, 9 and 15. That's an area over here. 9 is here. 15 is here. Well, again, we're going to need to do, it's an area of a right trapezoid, but the easier way again to do this is to find the area of the triangle that goes all the way from 9 to 17 on the bottom, and then subtract the one that only goes from 13 to 17. I'm sorry, 15, not 13. Okay, let's get this right. 15. Okay, that looks like we're at least approximately at 15. Okay, there we are. So something that looks like that. Now we know again the height here at this end is 2/11. We need to figure out the height here. Okay, so let's go back over here. So now we're looking at a picture like this. We're going to find this total area here. This is 2/11. This goes from 9 to 17 for a base of 8. Let's make sure that's right. 9 to 17, yeah, 8. 1, 2, 3, 4, 5, 6, 7, 8 for the base. And height is 2/11. So that area is, what's that area? Well, that area is 1/2 base times height. And the base this time is 8. And the height is 2/11. See, 2's are going to cancel here. And we're going to get 8/11. Now that's for that whole triangle. Now what we want to do, but that's not what we want. We want to only go out here to wherever 15 is. Okay, and just do this. So we want to subtract off that little triangle there that's unshaded. So we want to subtract another 1/2 base times height. This is a base 1, height 1. This is a second base in height. Alright, what's the base there? Well, from 15 to 17, that's 2. 17 minus 15 is 2 for the base. What is that height? Well, that height is going to be given by the formula for the PDF that we computed earlier. That's why we took the time to do that. And besides the fact that it asked us to find it, but why we need it is, there it is. So we're using this formula, negative 1 over 44 x minus 17. Negative 1 over 44 x minus 17. What's x? Let's see. In this case it's 15. So this is negative 2. Negatives cancel. 2 cancels. Makes this, see, these 2's cancel. Negative 2 cancels the negative, and 2 over 44 is 1 over 22. Multiply by 2 over 2 here, and we get 16 over 22 minus 1 over 22 is 15 over 22. And that is the, what is that? Well, that's the probability that x is between 16 and 17, or no, between 9 and, sorry, wrong, 9 and 15. And that's what we're looking for. what does that equal? 15 over 22. Point 68181818181. Or if we go to 4, 681.8 and then 1, so it rounds off to 0.6818. And that's what this is telling me as well, so that's a good check. Alright, let's see what else we've got. One or two more, just one more. Between 8 and 14. This is the hardest one, if I remember right, because here we go from 8 to 14. It's this total shaded area that I have here from 8 to 14. And the problem is I've got sort of two ways I could do it. I could find this area and this area separately and then add them up. Or the easier thing to do is to find the total area, which is 1, and then subtract off these two triangular areas. And that's what we're going to do. We're going to do that. So that was between 8 and 14. Okay, and what we ended up with looks something like this. We're going to take away, we end up keeping this part in here, but we're going to subtract off these two triangular pieces. So it's 1 minus the one triangle, 1/2, base 1, height 1, minus the other triangle, 1/2, base 2, height 2. Okay, let's see if we can figure this out. So this first one goes from 6 to 8. That's base of 2. So going from 6 to 8 is a base of 2. Kind of get my template here and I'll fill in the blanks. And what's its height? Well, the height is given by that formula, and I got to use the right part of the formula. Where's my formula? There it is. And I'm using this part, 2 over 33 times x minus 6. 2 over 33, x minus 6, and x is, here's the height right here, and what's the x value there? 8. So this is 2 times 2 is 4. So the height is 4 over 33. Base is 2. Of course, we have our 1/2. So that gives us an area of, this cancels, of 4 over 33 for that little triangle. 4 over 33 is the area right here, the unshaded area. Now do the same thing down here on this end. This one, if we look at it right, it goes from 14 to 17. So from 14 to 17, that's a distance of 3, so that's the base. And the height is going to be this thing right here at 14. So this is 14 minus 17. I forgot the slope. It's some negative number. What's the slope there? Keep running by it. There it is. Negative 1 over 44. X minus 17. We got the x minus 17, 1 over 44. So 14 minus 17 is negative 3. Cancels out, makes 3 over 44 for the height. Base is 3. Of course, you always have our 1/2. So this is 9 over 88. And I can get a common denominator here. I'm gonna get lazy here and just use a calculator. So it's 1 minus 4 over 33 minus 9 over 88. Now here it is in decimal form. Seven 751. And the 5 and the 1 keep repeating. And then we can do this, watch this in the calculator, go to math. The first thing says change to a fraction, so just hit enter twice and it'll change our last answer into a fraction. So the exact value is 205 over 264, which is what we've gotten if we'd done a common denominator there and done it by hand, common denominator. So the exact value of the probability is that, and we'll round it off to 7765 there, 0.7765. Okay, let's go ahead and check that answer. Hopefully I didn't make any, it didn't like something. Part does it not like? Oh, looks like I left out a negative sign on the slopes. Yeah, of course those are negatives. I just didn't type in the negative there. I should have. The slopes are always negative on that part that's coming down. Everything else is fine. Alright, there we go. And that gives you an example of a triangular distribution.